This video is going to have a look at titrations. There are going to be two parts to this. The first part is going to be how to carry out an accurate titration, and the second part is going to be how to use the results from the titration in calculations. I've put a link below this into the learning platform to show you how to carry out a titration. You'll have done it in class as well, so it should just be a bit of a recap for you. First things first though, the rules. The bottom of the water, the meniscus line, should always be on the zero line when you start. This bottom bit here shows you that you've got 0 mil on that line. If it's below that, you're reading it wrong. The second rule is always make sure you're reading it from eye level. So if you need to move the burette down, or if you need to stand up a little bit higher, do that, but make sure you read it at eye level, because if you're reading it from down here, you might read something slightly different. So make sure you're reading it exactly level with the waterline. Third rule is always in your first attempt do an approximation. So turn the tap, let the acid go into the alkali, and then when the colour changes and stays changed, stop it. So just let it run all the way through so you can get an approximation. So it might be approximately 26 mil, change the colour permanently. What you would then do next time is go down to about 23 mil and then put it in drop by drop to make sure you get exact readings. So you want that one drop that turns it from the colour it was to the colour it changes to and stays permanent. So the aim is, once you've done it with your practice attempt in the first time, you should be able to repeat and get 3 lots of accurate results, so within approximately 0.1 centimetre cubed. You should then be able to use results from your calculations, from your titrations, to work out concentration, moles and volume. Now this you'll have seen before. This is moles, this is volume, and this is concentration. So here's an example question. So you might get a question like this. 25 ml of sodium hydroxide has a concentration of 0.1 moles per decimeter cubed. 30 ml of H2SO4 neutralizes it. What is the concentration of H2SO4? The first thing you need to do is write down a balanced symbol equation. So write down that and then balance it. The next thing you need to do is write in the information that you know. So I know I've got 0.1 moles per decimeter cubed of sodium hydroxide. I know I've got 0.025 decimeters cubed of sodium hydroxide and 0.03 decimeter cubed of sulfuric acid. Remember, to work it out in decimeter cubed, you divide by 1,000. So 25 divided by 1,000 gives you that. Now, my moles is concentration times volume. So 0.1 times by 0.025, which gives me 0.0025 moles of sodium hydroxide. This is where the balancing of the symbol equation comes into effect. So I've got 2 NaOHs and only 1 H2SO4. To work out the number of moles of H2SO4, I divide that by 2. So 0.0025 divided by 2 is 0.00125. Then the final little bit is I need to work out the concentration here. Now I know concentration is moles divided by volume, so it's 0.00125 divided by 0.03, which will give me a concentration of 0.0417. And again, make sure you put your units in, moles per decimeter cubed. Okay, second example. I've got a question that says what volume of 0.5 moles per decimeter cubed hydrochloric acid will neutralize 20 ml of 1 molar sodium hydroxide. So the first thing you do is you write out your equation. It's already balanced in this case, so you don't need to do anything there, and then you fill in the information that you know. So I know I've got 0.5 and I've got 1 molar sodium hydroxide. I also know I've got 20 mil, so 20 centimeters cubed of sodium hydroxide, so I divide that by 1000, which gives me 0.02 decimeters cubed. To work out the moles, it's concentration times volume, so 1 times by 0.02, which is 0.02. And if I've got a ratio of 1 to 1, I don't need to do anything up here, the moles stays the same. So now I've got the number of moles, I've got the concentration, so the volume is moles divided by concentration, which is 0.02 divided by 0.5. That comes out to 0.04 decimeters cubed, which if you wanted to, you could times that by 1000, that would give you 40 centimeters cubed. Final example. It says Dave titrates an unknown concentration of H2SO4 with 25 ml of 0.1 molar sodium hydroxide. These are his results. Work out the concentration of H2SO4. So again, the very first thing you do is write down your simple equation. The next thing you need to do is balance it, and then fill in the information you know. So I know I've got 25 mil, which is 0.025 decimeters cubed. I know I've got a concentration of 0.1. I can therefore work out the number of moles of sodium hydroxide, which is concentration times by volume. So 0.1 times by 0.025 gives me 0.0025. Now again, as you've seen in one of the previous calculations, because I've got a ratio of 2 to 1, I divide by 2 to get that, which gives me 0.00125. Now, to work out the volume, I have to work out an average of this. So what I do is add them together, and then divide by 3, which comes to 67.5 divided by 3, which works out at 22.5. The next thing I need to do is put that into decimeters cubed, which is 0.0225. So that goes into my volume here, and then I can work out my concentration, which is moles divided by volume, so it's 0.00125 divided by 0.0225, which comes out to 0.056 recurring. Again, have a look at some of the practice questions. If you've got any questions there, just come and see me.